Hi everyone, this is Glenda Ganzon and welcome to my Human Anatomy and Physiology class. And for today's lesson, I'm going to introduce to you the other forms of inorganic compounds which are essential to human life, and they are the salt, acid, and base. First of all, I would like to introduce what salt is. You need to know that salts are formed when ions form ionic bonds. In these reactions, one atom gives up one or more electrons, thus becomes positively charged, whereas the other accepts one or more electrons and becomes negatively charged. So you can now define a salt as a substance that, when dissolved in water, dissociates into ions other than hydrogen or hydroxide. This fact is important in distinguishing salts from acids and bases. A typical salt or sodium chloride dissociates completely in water. The positive and negative regions on the water molecules, which are the hydrogen and oxygen ends respectively, attract the negative chloride and the positive sodium ions, pulling them away from each other. Again, whereas nonpolar and polar covalently bonded compounds break apart into molecules in solution, salts dissociate into ions. These ions are electrolytes and they are capable of conducting an electrical current in solution. And this property is critical to the function of ions in transmitting nerve impulses and prompting muscle contractions. This picture is the dissociation of sodium chloride in water. Take note that the crystals of sodium chloride dissociate not into molecules of the sodium chloride but into the sodium cations and chlorine anions, each completely surrounded by water molecules. That's why many other salts are important in the body. For example, bile salt produced by the liver help break apart dietary fats and calcium phosphate salts from the mineral portion of teeth and bones. This time, let me introduce to you what acid is. So an acid is a substance that releases hydrogen ions in solution. Because an atom of hydrogen has just one proton and one electron, a positively charged hydrogen ion is simply a proton. This solitary proton is highly likely to participate in chemical reactions, and strong acids are compounds that release all their hydrogen in solutions. That is, they ionize completely. Hydrochloric acid, which is released from cells in the lining of the stomach, is a strong acid because it releases all its hydrogen in the stomach's watery environment. So these strong acids in digestion and kills ingested microbes. Weak acids do not ionize completely. That is, some of their hydrogen ion remain bonded within a compound in solution. For example, a weak acid is vinegar or acetic acid, and it is called acetate after it gives up a proton. This is a picture of acids and bases, and in figure A is an example of an aqueous solution. An acid dissociates into the hydrogen ions and anions. Nearly every molecule of a strong acid dissociates, producing a high concentration of hydrogen. And in figure B, in aqueous solution, a base dissociates into hydroxyl ions and cations. Nearly every molecule of a strong base dissociates, producing a high concentration of hydroxide. And the last one that I'm going to introduce to you is the base. So what is a base? A base is a substance that releases hydroxyl ions in solution, or one that accepts hydrogen already present in solution. So the hydroxyl ions or other base combined with hydrogen present form of a water molecule, thereby removing hydrogen and reducing the solution's acidity. So strong bases release most or all of their hydroxyl ions. Weak bases release only some hydroxyl ions or absorb only a few hydrogen. Food mixed with hydrochloric acids from the stomach would burn the small intestine, the next portion of the digestive tract after the stomach. If it were not for the release of bicarbonate, a weak base that attracts hydrogen, bicarbonate accepts some of the hydrogen protons, thereby reducing the acidity of the solution. And for our last topic is the concept of pH. The relative acidity or alkalinity of a solution can be indicated by its pH. A solution's pH is the negative base 10 logarithm of the hydrogen ion concentration of the solution. As an example, a pH 4 solution has an hydrogen concentration that is 10 times greater than that of a pH 5 solution, that is, a solution with pH of 4 is 10 times more acidic than a solution with a pH of 5. The concept of pH will begin to make more sense when you study the pH scale, like in this picture. The scale consists of a series of increments ranging from 0 to 14. So a solution with a pH of 7 is considered neutral, neither acidic nor basic. Pure water has a pH of 7, and the lower the number below 7, the more acidic the solution is, or the greater the concentration of hydrogen, the concentration of hydrogen ions at each pH value is 10 times different from the next pH. For instance, a pH value of 4 corresponds to a proton concentration of 10, or while a pH value of 5 corresponds to a proton concentration of 10 to the 5th power. The higher the number above 7, the more basic or alkaline the solution, or the lower the concentration of hydrogen ion. Human urine, for example, is 10 times more acidic than pure water. This time, let's take the buffers. The pH of human blood normally ranges from 7.35 to 7.45, although it is typically identified as pH 7.4, and this is slightly basic pH. Blood can reduce the acidity resulting from the carbon dioxide constantly being released into the bloodstream by the trillions of cells in the body. Homeostatic mechanism, along with exhaling carbon dioxide while breathing, normally keep the pH of blood within this narrow range. So this is critical because fluctuations, either too acidic or too alkaline, can lead to a life-threatening disorders. Because all cells in the body depend on a homeostatic regulation of acid-base balance at a pH of approximately 7.4. The body therefore has several mechanisms for this regulation involving breathing, the excretion of chemicals in urine, and the internal release of chemicals collectively called buffers into the body fluid. So what is a buffer? A buffer is a solution of a weak acid in the conjugate base. That's why a buffer can neutralize small amounts of acids or bases in the body fluids. For example, if there is even a slight decrease below 7.35 in the pH of a body fluid, the buffer in the fluid, in case acting as a weak base, will bind the excess hydrogen ions. So in contrast, if pH rises above 7.45, the buffer will act as a weak acid and contribute hydrogen ions. So this ends our lesson about the other forms of inorganic compounds which are essential to human life, and they are the salts, acids, and bases. If you have any question, please write it into the comment section down below, and I'm glad to answer them all. Once again, thank you so much for watching this video and for listening to my discussion. Until my next video, bye!